Hello everyone. In this video, we will discuss about the dispersion and this is in context to optical fibers. So basically dispersion is of two types, intramodal dispersion and intermodal dispersion. Intermodal dispersion appears only in the multimode fibers and intramodal dispersion is basically pulse spreading within the single mode. So for single mode, we will take this intramodal dispersion in account and for multimode fibers, intermodal dispersion is applicable. So, before discussing these two types of dispersion, what is the dispersion? So, any phenomena in which velocity of propagation is wavelength dependent. If the velocity of optical signal is dependent on wavelength, then there will be dispersion because of different reasons. That reasons will be discussed in later content. So basically in communication, dispersion is used to describe any process by which any electromagnetic signal, here we are talking about the optical signal. So any electromagnetic signal propagating in a physical medium is degraded because of the different wave characteristics. And wave characteristics basically depend on the frequencies of the signals. So various wave characteristics of the signal have different propagation velocity within the physical medium. Medium can be no, there any here medium can be air, water, or no medium. So basically, dispersion are of three types: particular in optical fibers, material dispersion, waveguide dispersion, and polarization mode dispersion. So intramodal dispersion is caused by these two dispersion, material dispersion and the waveguide dispersion. So here we have discussed that the wave characteristics depend on the wavelength or there are different propagation velocity of the signal inside the medium. So if we want to go through dispersion, first we need to discuss different types of wave velocities. So if we discuss different wave velocities, then first one is the plane wave velocity. So if any plane wave propagating along the z-axis in an unbounded homogeneous region having the refractive index of n1, and this wave is represented by this vector exponential j omega t minus j k 1 z. Then the velocity of a constant phase plane is given by v. V is equal to omega by k1 is equal to c by n1. Here n1 is the refractive index and omega indicate the frequency component. So this is the plane wave velocity. Now next, modal wave phase velocity. So for a modal wave propagating along z-axis. Here we are considering plane wave. Here we are considering modal wave propagating along the z-axis represented by exponential j omega t minus j beta t. Then the velocity of the constant phase is given by Vp is equal to omega by beta. So this is the phase velocity. This is wave velocity. Now next one is the group velocity. So what is the group velocity? So group velocity is the speed at which energy in a particular mode travel along the fiber. So basically this is the actual velocity with which signal information or optical signal is traveling down the fiber. So basically this is the speed with which optical signal travel along the optical fiber. So in normal condition, it is always less than the speed of light in that medium. And When the wave is traveling inside the optical fiber, then we observe some delay, and this delay is known as the group delay. So here we have discussed about the plane wave velocity, model wave velocity, group velocity, and the group delay. Now next, group velocity. If we have, you can numerical can be asked in final examination based on the group velocity and group delay. The group velocity is given by Vg, d omega by d beta. Group delay given by tau g. This is the formula, and all these quantities depend on the frequency as well as propagation mode. So, on the basis of this group velocity, we will describe the intramodal dispersion.